Compound types. Ooh. Compound types can group multiple values into one type. Rust has two primitive compound types, tuples and arrays. A tuple is a general way of grouping together some number of other values with a variety of types into one compound type. Tuples have a fixed length. Once declared, they cannot grow or shrink in size. We create a tuple by writing a comma-separated list of values inside parentheses. Each position in the tuple has a type, and the types of the different values in the tuple don't have to be the same. We've added optional type annotations in this example. Function main let tup parentheses I32 F64 U8 equal parentheses 506.41. The variable tup binds to the entire tuple because a tuple is considered a single compound element. To get the individual values out of a tuple, we can use pattern matching to destructure a tuple value like this. Function main let tup. Okay, so we'll say function main let tup. Oh, alright, so is this even a tuple? I don't think it is. I think I got so distracted last time I didn't even use a tuple. So here we are. Oh no, yeah, there's my tuple right there. Bucket. So let bucket put up here equal, and I've got two different types. They're not two different types. Well, we will say there's only one Ferris. So we got, oops. What did I just do? Oh, I'm putting. Okay. And lastly, we'll say 1. Yeah. So we have let tup equal some stuff. And then go down here and say let x, y, z equal bucket, right? And then print on the value of y is y. Well, okay. So let's do this. No, that's not it. Want this? Well, that certainly wasn't it. Oh, it's getting worse. Okay, so we're gonna like that, and then maybe we'll do that right there. Yeah, and we got that. And I should set up screen keys for myself. BRB. So screen key, long story short, the developer moved it to GitLab, which I like that. I approve. Also seems to be using Python 2. I'm not sure. I want to mess with dependencies and whatnot. So, where am I? Right. So, man, I'm checking because just got to see it. I just got to see that total time moving. Okay, we've got these guys in a, okay, so print on, we will say, excuse me. Let's do, change enter that thing. Oh, Lord. Oh. Yeah, kill that. Yes. Now, change enter that thing. We will say, there's only one Ferris. Exclamation point. Okie doke. So here we're just going to take Ew. One of these days I'll get good, and I won't use visual quite so much. So there's only one Ferris. See if that works. Nope. So it says could not compile variables. Well, let me read and see if maybe it's something that was supposed to go wrong. Oh, no, it's not. See, because oops. I want that to be y. So, right? Yes. Y. How about now? You gonna compile it now for me, little buddy? Error. Now let's see why. Not found in this scope. Huh. Ah, yes. Okay. So we will just do that right there. And we will copy. And how does this do? Paste. Yes. Okay. One more time. Down here. There's only one Ferris. Where's my exclamation point? I wonder why that is. Yeah. Yeah, it's real tiny. So, oh, dare make this bigger. That's not how you do it. Nope. That gonna do it? Oh, oh, whoa, 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 come back. Oh, it's getting worse. I'm making it worse. Yeah, yeah. Okay, so now's a good time to save and quit that. Oop, just kidding. Boop doo. I'm gonna let's see. Okay, I'm in the terminal, giving it the Q command, which means go away. And now I'm gonna restore the original window size with Control equals with Alt View. Appearance. Control numpad 0. Didn't see that coming. Alright. So we're here, and this program first creates a tuple and binds it to the variable tup. It then uses a pattern with let to take tup and turn it into 3 separate variables, x, y, and z. This is called destructuring because it breaks the single tuple into 3 parts. Finally, the program prints the value of y, which is 6.4. Well, let's get up in here and say, oh gosh, come on now. We want to say there's only change word to bloop bloop. And we will change letter. Hey, I didn't know if that would work or not. One last thing I have to visual for. So there's only X, Y, Z. Okay. X, Y, Z. And we'll give a little cargo run. Oh, what did that? Look at that. Oh, okay. So there's only Z, right? YX. So here I'm going to change a letter. C, L. Change it to Z. And then C. Nope, just kidding. Change a letter to X. And there's only one Ferris. Now, why is my exclamation point not showing up unless that's bit? Oh, Ferris is holding the exclamation point. We just can't see it because it's too close to the emoji. There we are. In addition to destructuring through pattern matching, we can access a tuple element directly by using a period, followed by the index of the value we want to access. For example, make sure you're recording. You are. For example, we can have function main x i32 f64 u8 equals 506.41. Let 500 equal x 0.0. Okay. Let 6.4 equal x 0.1. Let 1 equal x 0.2. So here we've created a tuple x and then makes new variables for each element by using their index. As with most programming languages, the first index in a tuple is 0. So that means I should be able to say, okay, so we've got let x, right, let the bucket. I wonder if this seems kind of familiar. Like maybe I tried this and it sort of hit the fan. So we'll see. No, don't do that. Do this. Okay. Then we're gonna see, it doesn't like my little char. Oh, I see. Right. So what we want is, we'll go ahead and put my semicode there, and then so bucket is going to be sort of the values, right? So, or the, not the values, the types, yes. Char. I did end up with all three the same. For the win. Okay, so we got char, and oh, but I don't have my one in quotes, in single quotes there, whatevs. So equal. Okay, so then we can go ahead and just whack that and say, yeah, I know. Get me over there. I'm learning about surround. So my brother says, I don't think that was it. I hit S. Yeah, well. Surround for another day. So we got, yep, my nice out of order tuple. And then in our print on, all right, so now we got to do, we got a let business going on. Okay. We're gonna say, come back. Let for reals equal bucket dot 0. Okay. And then we will say, it didn't do it. It didn't do it for me. Okay. Now we're gonna let Ferris, right, equal, okay, bucket dot 1. Then let many, as in how many, ironically, 1 index that bucket dot a 2, and then we can get rid of this stuff. Why not? Okay, so and then we gotta print them, right? Okay, so we're coming here. There's only, what do we say? Oof. I'm gonna make this smaller, guys. And by guys, I mean guy. Oop. Guy being me. Let's go ahead and just go to the end of the line there. So first off, there's only how many? There's only many. There's only bucket.many. There's only one bucket.one. Many is a mistake. It should be 0. No, many is 2. Just kidding. 2. Then we got bucket dot. There's only. Okay. There's only bucket 2 is many, right? Goodness. What was the point of destructuring it? Yeah. I don't think I'm not really accomplishing what they're trying to demonstrate. I'm just playing around. So now we have what's left? 0. Okay. And then the other thing that's left is to close it up. Any guesses whether this will work? Look at you. Look at you. I'm getting rid of you. You're fired. We're going to have this instead. And then we got to figure out where the crap I am. Alright, so it might be in desktop. Are we? Yes, we are. Okay, go ahead. We're going to go verbs and get out of here. If you're curious, this is a side note. If you're curious about how to make Ranger do that, dot Ranger takes you into a place and then takes you in somewhere, and when you leave, it plops you out where you left from. Dot space Ranger. Okay. Cargo run. So we have not found in the scope. Huh? Well, did I? Is it even where I am? Do I have another variables one? Okay, maybe this will do it. Golly. Oh, I didn't use it at all. Okay, so here we are. There's only one Ferris. Yes, very nice. And what will I do with this window? I don't want it right now, but I like being there. I guess I could do this business, but now I can't read. I don't like to send things to floating, but I will. Well, I don't remember telling you to go to Monocle. There it is. Oof. Oh, wow. Life hacks. Okay, so now the array type. Another way to have a collection of multiple values is with an array. Unlike a tuple, every element of an array must have the same type. Oh, I can do that. Arrays in Rust are different from arrays in some other languages because arrays in Rust have a fixed length, like tuples do. In Rust, the values going into an array are written as a comma-separated list inside square brackets. Okay, so this is actually kind of aggravating me. I'm gonna print own twice. We'll say, just kidding. Where am I? Okay, yank it, put it down there, and then I'll do change till t. Oh, t is until, and then comma, blam. So there's only many change t, comma. Oh, I hit change t period. Oh, come back. Change t, comma. There's only many Ferris. Change t, comma. I don't even know what I hit. Change t, comma. I did it again. Oh, there is no comma. Change t, that, for reals. Oh. Golly. Down here. Cargo run. Yes. Why did it only do it once? Because shouldn't it do the print on twice? Yeah, there we are. There's only one Ferris, son. Okay. Array type. Comma separated list, square brackets. F in main let A equal, what if you revive? Arrays are useful when you want your data collected on the stack rather than the heap, so you know where it is. We will discuss the stack and the heap more in Chapter 4. Or when you want to ensure that you always have a fixed number of elements. An array isn't as flexible as the vector type. Spoiler alert. A vector is a similar collection type provided by the standard library that is allowed to grow or shrink in size. If you are unsure whether to use an array or a vector, you should probably use a vector even though you don't know what it is. See Chapter 8. An example of when you might want to use an array rather than a vector is in a program that needs to know the names of the months of the year. It's very unlikely that such a program will need to add or remove months, so you can use an array because you know it will always contain 12 items. Okie doke. I'm going to go ahead and blast my whole main function. Like this. Delete inner brace for the win, question mark. Oh, look at that. I love how it fixes it for me. So now we are going to let months, because it tells us to. Yes. Okay, so let months equal. Q is not a month. Jan. Ooh, this could take a while. Feb. What did I even do? Comma. Why you no go? Mar. Maybe I'll just do the old ones. It says January, February, March, April, May. Yeah. Jan, Feb, Mar. Per. May. Yeah, so a little history lesson. There ain't no such thing as June. Is it June? Okay, so January, February, March, April, May. There's two that shouldn't be there. It's July and August. Okay, so here's June. June we get. June. There it is. June. Skip July, skip August. October. Ooh. October. November. December. So January is named after a Greek Roman god. February, not sure. March is when you go to war. Don't know about April. Don't know about June. Except they really sort of start here. I'm not sure about Jan and Feb. I guess they decided they'd reboot the calendar in the middle of the winter when they can't do anything. And then March is when you go to war. I'm not sure about April, May, June. But if you count them from here, we're gonna index at 1 when they're counting. 1, 2, 3, 4, 5, 6. I left out September. You know how I know? Because it's called Seven-timber. Sept, right? So we got 1, 2, 3, 4, 5, 6, 7. September, Oct, 8. October, November is 9. December is 10. Isn't that nice? And then I think the Caesars named some months after themselves, summer months. Stuck them in there. So now we have 12. You would write an array's type by using square brackets, and within the brackets include the type of each element, a semicolon, and then the number of elements in the array, like so. Let A equal I32 semicolon 5 in square brackets. Just kidding. Let A colon I32 semicolon 5 equal 1, 2, 3, 4, 5. Here, I3 is the type of each element. After the semicolon, the number 5 indicates the element contains 5 items. They really just gave me this months thing, and then they're like, here you go. You're not going to be able to use it because you don't know about strings and whatnot. You might have read it once, but you forgot. Okay. Writing an array's type this way looks similar to an alternative syntax for initializing an array. If you want to create an array that contains the same value for each element, you can specify the initial value followed by a semicolon, and then the length of the array in square brackets, as shown here. Let A equal 3 semicolon 5. The array named A will contain 5 elements that will all be set to the value 3. Initially, this would be the same as writing let A equal square brackets 3, 3, 3, 3, 3, but in a more concise way. Accessing array elements. An array is a single chunk of memory allocated on the stack. You can access elements of an array using indexing like this. Fun main, let A equal, and then square brackets 1, 2, 3, 4, 5. Let first equal A square brackets 0. Let second equal A square brackets 1. I've just noticed that this is Fira Sans instead of Fira Code. In this example, the variable named first will get the value 1 because that is the value at index 0 in the array. The variable named second will get the value 2 from index 1 in the array. Okay? Invalid array element access. What happens if you try to access an element of an array that is past the end of the array? Say you change the example to the following code, which will compile, but exit with an error when it runs. It says we have an array A, 1, 2, 3, 4, 5. Let index equal 10. Let element equal A index. Print on. The value of element is element. Running this code using cargo run produces the following result. A bunch of stuff, and then it says panicked at index out of bounds. The length is 5, but 10. Wait, what? Oh, the length is 5, but the index is 10. The compilation didn't produce any errors, but the program resulted in a runtime error and didn't exit successfully. When you attempt to access an element using indexing, Rust will check that the index you've specified is less than the array length. If the index is greater than or equal to the array length, Rust will panic. This is the first example of Rust's, okay, wait a minute, greater than or equal to. I guess it's because they index, it's zero indexed. So if you attempt to access an element using indexing, okay, whatevs. This is the first example of Rust's safety principles in action. In many low-level languages, this kind of check is not done. When you provide an incorrect index, invalid memory can be accessed. Rust protects you against this kind of error by immediately exiting instead of allowing the memory access and continuing. See Chapter 9. Okay, let's do this. So we have let months equal, there's only 10 of them. Haha. But we know there's supposed to be 12 months. So we'll say, let index, I thought about using a different word there, but gosh, who knows? Who knows when they're doing keyword? Oh, I know. It's because the word let there. That is a variable. I can call it what I want. So let, end. Let's call it the end of the year. Let end equal months 12. I'm doing this wrong. Let end equal 12. Yes, okay. Let shush Christmas. Haha. Let Christmas equal months end of the year. Okay, so now we have Christmas is we haven't done. Okay, so you're right. You're right, book. It's not telling us there's a problem, except for we got to do something with Christmas. Printle. We wish you a merry reference to variable. We wish you a merry Christmas. Yes. And then that. So we're looking happy. Looks happy. So now we come down here and we say, run it. Index out of bounds. The length is 10, but the index is 12. Yeah, see right here where they used index as the variable name? I guess it was supposed to simplify things, but that could confuse me, because what if I thought I had to call this index?